You walk into a small room built to absorb every sound. No fridge hum, no traffic, no air conditioner running anywhere nearby. The engineer warns you most people don't last long inside. You think, how loud can nothing possibly be? 10 seconds in, you hear your own pulse tapping in your ears. 20 seconds in, you hear blood moving through your neck. A minute in, your own breathing gets loud enough that you notice every inhale, and you start looking for the door. The room isn't broken. Your ears are working exactly the way they were built to work. Something about total silence pulls sound out of your own body, and until recently, nobody could fully explain why. This room exists, and it has a name: the Orfield Labs Anechoic Chamber in South Minneapolis. Guinness measured it at -9.4 decibels in 2004, quiet enough that it briefly held the record for the quietest place on Earth. The walls are lined with foam wedges roughly a meter deep, built to absorb every echo before it can bounce back. Stephen Orfield, who runs the lab, has said the longest anyone managed alone in total darkness is about 45 minutes. Most visitors ask to leave inside of 20. People inside report hearing their own joints click when they shift their weight. They report hearing digestion working. One visitor said their heartbeat got loud enough to count without trying. None of it comes from imagination. A body never stops making noise, and on most days, everything else around you drowns it out completely. Human hearing is tuned to catch almost nothing at all. At the threshold of hearing, your eardrum moves a distance smaller than the width of a single hydrogen atom. That sensitivity exists so you can catch a twig snap 50 feet away, or a whisper across a crowded room. Take away every outside sound, and that same sensitivity turns inward. Blood pushing through the vessels near your inner ear becomes audible. Muscles holding your jaw and neck in place generate a low creak you'd never notice on most days, when everything else is making sound too. There's also a stranger source. Roughly half of people, tested in strict silence, can detect a faint tone their own cochlea generates without any outside input at all. Researchers call these spontaneous otoacoustic emissions, picked up with a microphone placed right in the ear canal. No headphones required. Your inner ear doesn't just receive sound. Under the right conditions, it produces some of its own. This next fact explains why silence can feel loud instead of just noticeable. When the incoming signal from your ears drops, the auditory pathway running through your brainstem doesn't go quiet along with it. It turns its gain up, the same way an amplifier boosts a weak signal to keep the volume steady. Researchers studying tinnitus, including work from Joseph Rauschecker at Georgetown, describe this process as central gain. Turn down the input, and the brain compensates by amplifying whatever signal is left, including its own background static, which helps explain why nearly 15% of adults report ringing or hissing they can't otherwise account for. Put those same people into total silence, and a ringing that stayed faint through a normal, noisy day becomes the loudest thing in the room. Silence carries a second, older meaning that has nothing to do with your ears and everything to do with staying alive. Step into a forest where insects and birds are calling constantly, and that background noise means the area is calm enough for smaller animals to keep making it. Naturalists have described the reverse for generations. When that constant chatter cuts out all at once, it usually means something moved through. A predator, a threat. Something the smaller animals spotted before you did. Hunters use that exact cue on purpose. Prey animals go still and silent themselves the moment they sense danger. So a sudden hush spreading across a whole area often works as the loudest warning available. Humans evolved inside that same signal system for most of our history. A sudden absence of ambient sound didn't mean safety. It meant, pay attention, right now, immediately. In 1954, psychologist Donald Hebb ran an experiment at McGill University, testing how much outside input the mind actually needs to stay stable. Students were paid, generously for the time, to lie on a bed in a quiet, dim room, wearing translucent goggles that let light through but blocked every shape, with cardboard tubes over their hands to cut off touch. Most were told they could leave whenever they wanted, no questions asked. Almost none of them lasted more than 2 or 3 days. Many reported hallucinations within hours, patterns, voices, shapes crawling across their vision. Without sound or texture or detail left to process, several participants described their own thinking turning foggy and disorganized, a result they hadn't expected from simply lying still in a quiet room. That effect didn't stay inside a lab. Psychologist Craig Haney at UC Santa Cruz has spent decades studying prisoners held in solitary confinement, where extended isolation and near total quiet are part of the design, not a side effect of it. Interrogation rooms apply the same principle on purpose. Strip away sound and stimulation, and people start filling the gap themselves, with anxiety, with imagined threats, with their own thoughts running louder than they'd ever get during an ordinary day. Silence, used this way, works as pressure in its own right, built entirely out of what your own nervous system does the moment you give it nothing else to process. There's a social version of the same mechanism. Psychologist Kipling Williams at Purdue built an experiment called Cyberball, where a participant plays a simple ball-tossing game online against two other players, except the other two are simulated, and at some point they just stop passing the ball. No insult, no argument, just quiet exclusion. Brain scans taken during that exact moment show activity in the dorsal anterior cingulate cortex, a region also active during physical pain. Getting cut off from sound and getting cut off from other people seem to run through overlapping wiring. Neither gap reads as neutral to the brain. Both get read as something happening to you right now. So back to that room in Minneapolis, foam walls absorbing every echo, a door that seals shut with a soft click. Nothing in there generates sound on purpose. Your blood keeps moving. Your joints keep shifting. Your cochlea might be humming on its own, and your brainstem keeps turning up the gain on all of it, because the outside world just stops supplying anything else to listen to. Silence carries its own kind of noise. It works like a mirror held up against your own nervous system, and whatever your body already produces gets reflected straight back at a volume you never noticed before. That's why the quietest room you'll ever stand in can end up being the loudest thing you hear all year.